What if I told you that everything you believed about the lives of indigenous peoples is untrue? For many years, researchers overlooked the subtle engineering solutions that allowed people to sleep comfortably during the most destructive nighttime rainstorms. These architectural approaches combined a deep understanding of the physics of materials and the principles of thermoregulation. The inhabitants of the Great Plains and Eastern Woods created dwellings that could withstand days of rainfall without a single drop inside. Watch the video to the end to learn how collective housing and the unique properties of natural shelters saved entire settlements from night storms. What academic researchers are hiding is the remarkable aerodynamics of traditional shelters in the Great Plains. The conical shape of the dwelling was not created for aesthetics, but as the ideal tool for deflecting powerful streams of water. During a nighttime downpour, raindrops did not linger on the surface but rolled rapidly down the sloping walls. The sharp angle of inclination prevented moisture from accumulating, eliminating the risk of the material sagging under the weight of precipitation. Water drained into the ground outside the interior space, leaving the living area completely dry. The structure was supported by a complex frame of long, sturdy poles, connected in a special way at the top. These supports were installed at a precisely calculated angle, forming a stable base against strong winds. The tension of the outer covering was adjusted with special pegs driven deep into the dense soil. The tight fit of the layers of material prevented cold, damp air from entering the interior. The people inside were completely safe from the raging weather outside. The processing of the outer covering also deserves separate detailed consideration. The canvas was sewn from a multitude of carefully prepared elements, forming a single monolithic dome. The seams were positioned so that water would run off them without finding a way inside. Strong tendons were used for stitching, which swelled when wet and tightly sealed any microscopic holes. This natural property of the materials turned an ordinary seam into a waterproof barrier. At the top of the cone were special ventilation valves that regulated airflow. During rain, these elements were closed with long poles, forming a tight waterproof cap. Careful adjustment of the valves allowed heat to be retained inside, preventing moisture from entering through the smoke hole. Sloping blades directed drops away from the central fire, protecting it from being extinguished. Proper control of these valves required a deep understanding of wind direction and precipitation intensity. Heat retention in high humidity conditions was ensured by an internal screen. This additional canvas was attached to poles at human height and descended to the ground. The screen created an air gap between the damp outer wall and the dry interior. Cold air descended along the outer contour without affecting people's sleeping areas. This ingenious thermoregulation system worked on the principle of a modern thermos, maintaining a stable microclimate. This experience shows how deeply the inhabitants of the plains understood the laws of physics and the properties of natural materials. Every detail of their daily life served one great purpose: to ensure safety and comfort. Strict adherence to the rules for setting up a shelter guaranteed protection from any vagaries of the harsh climate. We would be very interested to hear your opinion on such weather protection technologies. Please write about it in the comments. And be sure to subscribe to our channel to continue discovering the secrets of the engineering art of the past. Are you ready to learn the truth about collective survival in the harsh forests of the Northeast? The inhabitants of these territories built large-scale wooden structures known as longhouses. These structures reached several dozen meters in length and housed many related families. The massive wooden frame was covered with huge layers of elm or cedar bark, laid in overlapping layers. Like fish scales, these layers diverted water flows, preventing them from entering the living quarters. The bark for the roof was harvested in the spring, when it was most flexible and easy to remove from large trunks. It was straightened under a press made of heavy stones and dried to a state of strong and even panels. When laid on the frame, these panels were tightly tied with flexible spruce roots or linden bast. The overlap of the layers was calculated with perfect accuracy to cover all possible joints and gaps. Rain of any intensity simply rolled off these natural shields straight onto the ground. Sleeping platforms in longhouses were constructed in 2 tiers to save space and conserve heat. The lower tier was used for sleeping, while the upper tier was used as a shelf for storing things or as an additional place to rest. On cold, rainy nights, the lower beds were covered with thick skins, creating closed, warm capsules. The enclosed space of these niches quickly heated up from the breath of the sleeping people and the warmth of the central fires. The thick curtains prevented drafts and maintained a comfortable temperature until morning. Keeping the fires burning required a constant supply of dry firewood inside the room. Special sections near the entrances were set aside for storing wood, protected from street moisture. Properly dried firewood burned evenly and emitted almost no acrid smoke, which was critically important in an enclosed space. Ventilation holes in the roof provided the necessary draft, removing combustion products to the outside. During heavy rain, these holes were partially covered with pieces of bark to prevent the fire from being flooded. Collective sleep played a vital role in maintaining body temperature during harsh cold nights. People huddled close together, warming each other under shared dense shelters. This joint thermoregulation allowed them to comfortably endure sudden temperature changes during autumn storms. The feeling of a friend's or relative's elbow provided not only physical warmth, but also a sense of absolute security. In such a large and close-knit community, it was much easier to withstand the forces of the raging elements. The elm and cedar wood from which the house was built had natural antiseptic properties. The resinous vapors from the wood created a pleasant microclimate inside, conducive to healthy and deep sleep. The walls absorbed excess moisture from the air, preventing condensation from forming on the sleeping areas. In the morning, when the rain stopped, the wooden panels quickly released the moisture to the outside under the influence of the wind. This natural climate control made longhouses one of the most advanced structures of their time. The traditions of constructing such buildings were passed down from generation to generation without the use of complex tools. The craftsmen relied solely on centuries of experience and a deep understanding of the laws of the environment. The result was structures that surpassed many modern counterparts in terms of reliability. Do you think modern engineers could replicate such a design without using nails or metal? In the next chapter, you will learn about the unique natural insulators used to protect against the icy northern winds. The hidden truth that everyone is silent about lies in the unique insulating materials of the past. Natural porous structures were actively used to protect against soil freezing and preserve heat. Dry sphagnum moss collected during the warm months became the ideal layer between the ground and the bed. This moss had an incredible ability to trap a huge amount of air inside its thin fibers. It was this air that acted as a reliable barrier, preventing the cold from the wet ground from reaching the sleeping people. Collecting moss was a long process that required knowledge of specific places where it grew. The plant was carefully cut, avoiding damage to the root system, and laid out in the sun until it was completely dry. The dried material became light, fluffy, and completely devoid of natural moisture. It was stuffed into special bags made of soft leather, creating something similar to modern orthopedic mattresses. These mattresses perfectly molded to the shape of the body, ensuring a good night's sleep after a hard day. The skins of large herbivorous animals served as the main material for making warm sleeping bags. Winter fur had a thick undercoat that perfectly retained the natural heat of the human body. These covers were carefully cleaned and kneaded by hand until they became incredibly soft and elastic. Blankets made from them were sewn with double stitching to prevent heat loss through small gaps. A person wrapped in such a cocoon could sleep peacefully even when the outside temperature was below freezing. Particular attention was paid to the multi-layered nature of the night shelter. The bottom layer consisted of mats, the middle layer of fluffy skins, and the top layer protected against drafts. Air pockets formed between the layers, working on the principle of multi-chamber double glazing in modern windows. This layered system allowed the temperature to be regulated depending on changes in the weather outside the dwelling. If it became too hot, the top blanket was simply thrown aside without losing the main heat. The preparation of the sleeping area began long before the onset of evening darkness and bad weather. People carefully beat moss mattresses, restoring their original volume and elasticity. Each mat was checked for damage, and the skins were spread out to cover as much area as possible. This daily ritual ensured high-quality sleep and no unpleasant surprises at night. Meticulous attention to detail was the key to good health and survival in the wild. Insulating the dwelling also included protecting the entrances from icy air currents. Door panels were made of a double layer of stiff leather reinforced with wooden crossbars. At night, the entrance was additionally covered with a heavy canopy, the edges of which were pressed tightly to the ground with stones. This barrier prevented the appearance of treacherous drafts that could cool the room in a matter of minutes. Inside, a cozy atmosphere was maintained, contrasting with the fury of the elements outside. The internal microclimate was also maintained by heated stones brought from the hearth. Large rounded boulders were heated in the fire and then placed in special recesses near the sleeping areas. The stones slowly released their accumulated heat energy throughout the long rainy night. This radiant heating system worked gently and did not dry out the air inside the shelter. People fell asleep in the pleasant warmth that evenly enveloped the space from floor to ceiling. The use of these natural technologies demonstrates the highest level of adaptation to environmental conditions. People did not fight nature, but wisely used its gifts to protect their livelihoods. This knowledge was accumulated over centuries, turning into reliable algorithms of action in case of any bad weather. I hope you found it interesting to learn about these hidden aspects of the life of indigenous peoples. If you like this material, be sure to like this video. Want to learn a secret that will change your life and your view of the history of waterproof fabrics? Before the advent of synthetic materials, the only reliable way to protect against water was through complex chemical treatment of organic materials. The craftsmen of the past transformed ordinary rawhides into high-tech breathable membranes. This process required enormous physical effort and a deep understanding of the reactions of natural tannins. The resulting material surpassed many modern equivalents for tourist equipment in terms of its properties. The first step was to carefully remove all traces of flesh and fat from the surface of the future fabric. Special scrapers made of durable bones or sharpened stones were used for this purpose. The canvas was stretched on a wooden frame, and the craftsman methodically cleaned every square centimeter of the surface. The slightest omission at this stage could lead to the material rotting in high humidity conditions. The perfectly cleaned surface became the basis for further chemical transformations. This was followed by a tanning stage using organic mixtures rubbed into the fiber structure. The mixture consisted of natural oils, plant extracts, and ash obtained from certain types of wood. This paste was rubbed in by hand for several hours, causing the fibers to soften and separate. The kneading process made the material incredibly pliable, similar to modern expensive suede. The fabric lost its original stiffness, becoming suitable for sewing complex clothing and shelters. The use of this membrane in the construction of dwellings made it possible to achieve absolute dryness inside. Raindrops simply rolled off the smoked surface without leaving wet marks on the outside. Unlike modern plastic tents, this natural material allowed air to pass through perfectly. Natural ventilation prevented condensation from forming from the breath of people sleeping inside. It was the ideal solution for comfortable sleep in conditions of several days of heavy rain. Strong tendons, which also underwent special treatment, were used to sew the elements of the covering together. The tendons were dried, split into the finest fibers, and twisted into tight and strong ropes. When dry, such thread easily passed through holes made with a bone awl. When wet during rain, the thread swelled, tightly plugging the hole and blocking the passage of water. This natural sealing of the seams made the entire structure of the shelter monolithic and invulnerable. Maintaining such covers required regular inspection and timely repair of minor damage. If scuffing appeared on the surface, it was immediately treated with a fresh portion of natural oils or fat. If the fabric became heavily wet, it was carefully dried in the wind while stretched to avoid deformation. Periodically, the light smoking procedure was repeated to restore the water-repellent properties of the resinous film. Careful handling of the materials extended their service life for many decades of active use. Today, these technologies are admired even by engineers from leading equipment manufacturing companies. The natural membrane, created by hand thousands of years ago, remains unmatched in terms of environmental friendliness and comfort. Did you know that such complex chemical processes were used in ancient times? In the next chapter, you will learn how the architecture of shelters helped to cope with the strongest wind loads during a storm. Storms on open plains were always accompanied by squalls of tremendous destructive force. Protection from water flows would be meaningless if the shelter could not withstand the pressure of a hurricane. Therefore, the geometry of the structure was calculated taking into account aerodynamic principles of reducing drag. Sloping walls forced air currents to smoothly bend around the obstacle without creating excessive pressure on the facade. The wind pressed the structure to the ground, making it even more stable during severe weather. The basis of its strength was a frame made of massive wooden poles arranged in a rigid cone. These supports were connected at the top with a special knot that did not weaken under the influence of vibration. The thickness of the poles was selected so that they retained a slight flexibility in strong gusts of wind. The frame sprang slightly, dissipating the kinetic energy of the squall and preventing the load-bearing elements from breaking. This property of elastic deformation allowed the structure to withstand enormous dynamic loads without destruction. The system for attaching the outer canvas to the ground played a critical role in ensuring stability. Long, sturdy wooden pegs were driven deep into the ground at an angle opposite to the direction of tension. The loops at the bottom edge of the covering were made of thick leather, resistant to constant friction and jerks. During an approaching storm, the number of fixing pegs was doubled to provide additional strength. Careful tensioning prevented the sail effect, preventing the wind from tearing the protective fabric from the frame. In the longhouses of the eastern forests, wind protection was built on the principle of massiveness and integration with the landscape. Buildings were located in lowlands or behind natural barriers in the form of dense forests. The trees broke up the hurricane-force winds, reducing their strength before they collided with the wooden walls. The frame of thick tree trunks was a powerful, monolithic structure that was not subject to vibrations. Deeply dug support posts ensured a secure grip on the ground, preventing any movement of the structure. The interweaving of horizontal and vertical frame elements in longhouses created a rigid spatial frame. Each intersection was securely fixed with flexible tree roots, forming a strong and elastic connection. During a hurricane, the entire building functioned as a single monolith, distributing loads throughout its enormous volume. Transverse ceiling beams connected opposite walls, preventing them from moving apart under the weight of the wet roof. Inside such a house, people felt completely safe, as if in a stone fortress. The roofs of eastern houses had a gentle slope, which reduced wind resistance and the risk of bark sheets being torn off. The layers of bark were pressed down from above by an additional row of longitudinal poles, firmly tied to the main frame. This external pressure held the roofing material in place even during the most violent gusts of wind. The weight of the structure itself, combined with reliable fastenings, prevented any damage to the roof during storms. Rain and wind battered against the thick bark without causing the slightest structural damage to the building. Preparation for a night storm always included a thorough inspection of all joints and fastenings. People walked around the outside of their homes, hammering in loose pegs and tightening sagging fastening cords. Firewood was brought inside in advance to avoid having to go outside in the middle of a storm. Entrances were sealed shut with heavy wooden shields or tightly covered with thick, multi-layered skins. Complete isolation from the outside world allowed the community to calmly wait out the worst of the storm. The ability to withstand the wind was the key to safe sleep on rainy and stormy nights. Knowledge of aerodynamics, materials physics, and load distribution principles made the architecture of the past incredibly effective. These structures blended harmoniously into the landscape, becoming a natural extension of the complex environment. The structures withstood tests that often destroyed buildings of later colonial eras. Peaceful sleep in the eye of the storm was the result of thousands of years of experience of human interaction with the harsh natural environment. What you have never seen is hidden in the detailed layout of the sleeping areas. The interior space of the dwelling was divided into strict functional sectors, each of which had its own purpose. The hearth was located in the geometric center, serving as the main source of light, heat, and a place for cooking. Around the fire was an activity area, which was always kept free of personal belongings and bedding. Sleeping areas were set up along the walls, as far away as possible from the central passageway. The sleeping areas were raised above the level of the main earthen floor to protect against possible dampness. For this purpose, small wooden platforms were created, or thick cushions of compacted dry earth were piled up. This elevation prevented contact with moisture even in the event of severe flooding of the area surrounding the camp. The height of the platforms ensured that the sleeping person was in the warmest air zone rising from the hearth. The correct height was the key to a comfortable temperature and no drafts at floor level. A small groove was often dug around the perimeter of the interior space to collect any condensation. If moisture did penetrate the walls due to strong side winds, it would flow directly into this gutter. The water from the gutter was drained outside the shelter through special drainage holes at the base of the walls. This internal drainage system ensured that the sleeping platforms remained dry in all weather conditions. The engineering approach to water drainage is striking in its simplicity and absolute reliability. The location of people during sleep was strictly regulated by internal rules and traditions of the community. The head of the family and honored guests occupied the most prestigious and warmest places in the back of the dwelling. The younger generation and unmarried family members were located closer to the exit, performing the function of a kind of guard. This distribution ensured safety and a quick response in case of unforeseen nighttime situations. The order of placement was strictly observed, turning internal life into a well-coordinated and predictable mechanism. Lighting at night was provided by thick logs slowly smoldering in the central hearth. A bright flame was not necessary. The even, soft light of the coals was sufficient for basic orientation. The coals gave off steady heat without emitting thick smoke, which was important when the ventilation valves were closed. In case it was necessary to quickly start a fire, bundles of dry grass and birch bark were always kept on hand. Skillful handling of fire was a basic skill that ensured survival during periods of prolonged rainfall. To create a special atmosphere of comfort and freshness in the room, bundles of fragrant steppe grasses were used. Dried wormwood, sweetgrass, and sage were hung under the dome and exuded a pleasant natural aroma. This scent neutralized any musty odors, purifying the air in the enclosed space during prolonged rain. In addition, the essential oils of these plants had a calming effect on the nervous system of a tired person. Sleep in such a fragrant atmosphere was incredibly deep, even, and restorative after hard physical labor. The acoustic insulation system also deserves attention when studying the design of these unique structures. Thick, multi-layered walls made of leather or tree bark perfectly dampened the external noise of the raging weather. The rumblings of thunder and the howling of the wind reached the sleeping people only as a dull, distant hum. The soft materials of the interior decoration absorbed the echoes, creating acoustic comfort inside the room. This silence helped to reduce stress levels and ensured proper rest in difficult weather conditions. Every detail in the organization of the night space worked toward the common goal of survival and health preservation. The combination of these well-thought-out rules transformed an ordinary shelter into a comfortable home, ready to withstand any vagaries of the weather. This ideal structure of life was formed over decades through trial and error, an invaluable practical experience. Did you know about such strict rules for maintaining cleanliness and order in ancient settlements? In the next chapter, you will learn how collective experience helped predict bad weather long before it began. The ability to foresee an approaching rainstorm was the key to successfully preparing the entire camp for the onslaught of the elements. Experienced observers continuously read the signs of nature, recording the slightest changes in the environment over many hours. The shape of the clouds, their color, and their speed across the sky provided the most accurate information about the front. The appearance of high cirrus clouds, followed by a thick gray veil, signaled an imminent prolonged storm. This knowledge allowed preparatory work to begin in daylight, avoiding panic and confusion in the darkness of night. The direction and temperature of the wind served as another important indicator of imminent changes in weather conditions. A sudden gust of cold air on a warm day often heralded the formation of a powerful storm front. The ability to identify smells carried by the wind from long distances helped to detect the smell of ozone and damp earth. This characteristic scent of rain could be smelled dozens of kilometers before the first drops fell. The community was immediately alerted and began to wrap up outdoor work. Preparing the camp was a well-organized process in which each person knew their role. The first task was to check the tension of all the fastening ropes and the reliability of the anchor pegs. Stocks of dry firewood were urgently moved from outdoor storage to indoors, under the reliable protection of the roof. Food that had been drying in the open sun was quickly gathered and packed into waterproof leather covers. The speed and coordination of the entire group ensured that the camp was fully prepared for the onset of bad weather. Additional support poles were installed inside the longhouses in anticipation of hurricane-force winds. Thick logs propped up the central beams of the roof, taking on the excess structural stress. Women sewed clothes, decorated items with intricate embroidery, and prepared hot meals for the whole family. The period of bad weather turned into a time of intense communication, knowledge transfer, and storytelling of ancient legends. Forced isolation united the community, strengthening social ties between representatives of different generations. The importance of the hearth fire increased many times over during this time, turning the fire into the true center of the universe for the community. Maintaining an even and hot flame required special skill in selecting firewood from different types of trees. Hardwoods gave off a lot of heat and smoldered for a long time, maintaining a high temperature under the arches of the dwelling. Soft wood was used to quickly light the room when doing delicate craft work. The fire was never left unattended, with people assigned to monitor it at night. A supply of drinking water was also prepared in advance to avoid trips to the river during thunderstorms. Large clay jugs or leather water skins were filled to the brim and stored in a cool place. Having fresh water inside the dwelling provided comfort and quenched thirst after eating salty or dried food. This supply was strategically important as rivers often became murky and dangerous during heavy rains. The autonomy of the shelter was the main criterion for its readiness to withstand the forces of nature. Observation of nature and timely preparation of the camp eliminated the element of surprise when encountering a storm. People met the storm not in panic, but with calm confidence in the strength of their walls and the correctness of their actions. This confidence was based on centuries of experience, of generations who had learned to live in harmony with the harshest conditions. A rational approach to safety ensured peaceful sleep, even when a real hurricane was raging outside. The knowledge of their ancestors was the most reliable shield, protecting them from the vagaries of the changing climate. The changing seasons brought new challenges as autumn rains gradually gave way to fierce winter snowstorms. In northern regions and subarctic forests, preparing for the cold required special engineering solutions. Homes were additionally insulated with a thick layer of turf or a thick blanket of snow laid on top of the main roof. Snow, with its porous structure, served as an excellent heat insulator, preserving the precious warmth of the hearth inside the room. This natural coat transformed an ordinary wooden structure into something resembling an incredibly warm and cozy dugout. To prevent the floor from freezing, a continuous floor covering of thick spruce or pine branches was laid on the ground. The coniferous branches created an air layer several tens of centimeters thick, completely blocking the cold from the ground. On top of this green carpet, the thickest skins with dense winter fur were spread out, forming a luxurious warm bed. The scent of pine needles disinfected the air, preventing the development of diseases during long stays in enclosed spaces. In such conditions, the severe frosts outside the walls of the dwelling were not at all frightening to its inhabitants. Sleeping bags in subarctic conditions were sewn from caribou skins, whose fur has a unique structure. Caribou hairs are hollow inside, making this fur the best natural insulator on the planet. The bag was designed so that the fur was both outside and inside, close to the body. Crawling into such a cocoon, a person could sleep comfortably on bare ice at extremely low temperatures. This equipment remained the standard for polar gear until the very end of the 20th century. Ventilation of the winter shelter required precise adjustment so as not to let heat escape and not to suffocate from smoke. The smoke hole was made as small as possible, just large enough for the combustion products to escape. During heavy snowstorms, a special snow or ice canopy was erected over the opening to protect against backdraft. If the wind changed direction, the position of the canopy was quickly adjusted by the person on duty at the camp. The safety of the sleeping people depended on continuous monitoring of the condition of this complex ventilation system. Setting up camp in deep snow began with a large-scale clearing of the site down to the densest soil. The snow was thrown around the perimeter, forming a high protective wall that sheltered the dwelling from the icy, piercing wind. These snow ramparts took the brunt of the blizzard, creating an aerodynamic calm zone around the house. Inside such a wind tunnel, the temperature was always several degrees higher than in the open. The integration of the structure into the harsh winter landscape was the highest manifestation of architectural wisdom. In the conditions of polar nights and long snowfalls, the psychological health of the community came to the fore. Spacious dwellings became a place for general meetings, celebrations, and communal meals. Rhythmic music, singing, and stories told by elders helped pass the endless, dark hours of winter evenings. Moral support and a sense of belonging to a strong community prevented winter depression from developing. A strong spirit was as important a factor for survival as warm clothing and a reliable roof over one's head. Survival in winter storms proves the universality of approaches to thermoregulation among the peoples of the North and the Plains. The same physical principles that protected against autumn rains were used to combat ice storms. Layering, the use of natural insulators, and ventilation control saved people in the most extreme conditions. Peaceful sleep in the heart of a blizzard was the result of the flawless operation of the camp's complex life support system. This knowledge allowed humans to settle in the harshest and most inhospitable territories of the North American continent. The life of nomadic communities did not always allow them to wait out multi-day downpours in the comfort of a stationary camp. The need to follow migrating herds forced people to move even in the worst weather. The process of moving in the rain required meticulous logistics and reliable waterproofing of all valuable property. Shelters were assembled according to a strict algorithm to keep the contents dry until the last second. The frame was only dismantled after all the belongings had been securely packed and tied to the vehicles. The main means of transporting belongings across the plains was a volocouche, a rigid wooden frame. The cargo was placed on crossbars high above the ground, which prevented it from getting wet when crossing deep puddles. All the luggage was tightly covered with large sheets of waterproof smoked leather, fastened with strong straps. Water simply ran off this shell, leaving food, clothing, and bedding completely dry. A properly assembled volocouche was invulnerable to heavy rain during multi-day journeys. To protect the people themselves while on the move, long cloaks made of tanned leather or woven from bark fibers were used. These cloaks covered the body from head to knee, directing water away from the main warm clothing. Wide hoods protected the face and neck, maintaining visibility and preventing ice drops from getting down the collar. Special high moccasins, impregnated with melted fat to create a water-repellent effect, were worn on the feet. Such equipment allowed marching in the rain, maintaining basic warmth and preventing hypothermia. Dry firewood for the first fire at a new location was always carried in the special leather bags. Building a fire in the rain would have been impossible without this strategic supply of dry fuel and kindling. The flames that flared up under the newly erected dome instantly transformed the gloomy atmosphere of the wet journey into a cozy one. It allowed them to quickly dry their wet outer clothing and warm their frozen hands after hard work. The fire symbolized man's victory over the elements and a return to a familiar, comfortable life. Particular attention was paid to keeping weapons dry, as the livelihood and safety of the entire community depended on them. Bows were placed in long waterproof cases made of rawhide, which protected the elastic wood from deformation. The bowstring, made of sinew, instantly lost its properties when wet, so it was removed and hidden under the armpit. Arrows were stored in hard quivers, tightly closed with leather lids to insulate them from the damp environment. The combat effectiveness of the detachment was maintained at the maximum level, regardless of the intensity of precipitation. Knowledge of the terrain allowed them to plot routes along high ground, avoiding flooded valleys and muddy trails. The group moved on solid rocky ground, where the porters did not get stuck in the mud and did not lose their mobility. Navigating in poor visibility, when low clouds hid the sun and mountains, required a phenomenal memory. Expedition leaders guided people using barely noticeable natural landmarks, known only to experienced guides. Accurate navigation saved energy and time, allowing them to reach a safe place to spend the night more quickly. Arrival at a new location was accompanied by a strict ritual of inspecting all belongings for accidental moisture. If moisture did penetrate the luggage, the damaged items were immediately removed and sent for intensive drying. Sleeping places were arranged with particular care to compensate for the fatigue of the exhausting wet march. A warm dinner and a dry bed quickly restored the physical and moral strength of people exhausted by the long journey. The first night's sleep in a new place was always the deepest and most peaceful after successfully overcoming the elements. This level of mobility in extreme conditions amazes the imagination of modern city dwellers. The ability to move an entire village under pouring rain without losing comfort is evidence of the highest level of organization. The thoughtfulness of each piece of equipment made the nomadic lifestyle resistant to any natural disasters. These survival skills were honed over centuries, turning into a flawless system of logistics and protection. A safe sleep under a reliable roof was a worthy reward for hard work during a harsh transition. Studying the architectural and domestic solutions of the past opens up an amazing world of precise engineering calculations. The structures of the indigenous peoples of America were not just primitive shelters, but complex bioclimatic systems. They blended perfectly into the environment, using its resources to protect people from negative factors. The form, materials, and internal organization of the space worked in unison to provide maximum comfort. This approach to construction is radically different from the modern concept of conquering nature by brute force. The environmental friendliness of the materials used is one of the most important lessons we can learn today. All elements of the structures, from the wooden frame to the leather coverings and moss mattresses, were biodegradable. After the camp was abandoned, nature quickly recycled the remains of the structures, leaving no lasting waste on the ground. Man took from nature exactly what was necessary for survival and repaid the debt in full. This harmony with the ecosystem ensured the inexhaustibility of resources over thousands of years of continuous exploitation. The principles of thermoregulation inherent in the design of longhouses and conical shelters are used in modern architecture. The idea of ventilated facades, double walls, and thermal screens originates from these ancient technologies. Passive heating and cooling of buildings through proper geometry and location is becoming a trend in green building. Engineers are rediscovering the laws of physics that were intuitively understood and actively used by the craftsmen of the past. Architecture is returning to its roots, striving to achieve the same efficiency with minimal energy consumption. The art of leather processing and the creation of waterproof membranes remains an unsurpassed masterpiece of ancient chemistry. Modern tourists, using high-tech synthetic fabrics, often do not think about the evolution of these materials. The ability to predict a storm by the shape of the clouds and the smell of the wind was a basic skill that ensured safety. Returning to this connection with nature could make us more aware and prepared for unexpected changes. The observant and analytical minds of our ancestors remain an unattainable ideal for us in our interaction with the biosphere. The portable structures of the Great Plains nomads anticipated the development of modern mobile architecture by many centuries. The principles of modularity, ease of assembly, and high strength are at the heart of the creation of space stations and polar bases. The idea of creating a reliable, autonomous shelter that can be quickly deployed anywhere on the planet was born in the steppes. The genius of these solutions lies in their extreme simplicity, which cuts out everything superfluous in favor of functionality. Every detail had a meaning and worked toward the overall result without the slightest glitch. The preservation of this knowledge and oral tradition, without the use of written drawings and formulas, is astonishing. Technologies were passed on through practice, from master to apprentice, during joint work on setting up camps. We can only admire how elegantly and effectively the most complex tasks of ensuring comfort were solved. Their homes were real fortresses, protecting the most valuable thing: the life and health of future generations. The experience of our ancestors will forever remain a brilliant example of the harmonious coexistence of humans in the harsh environment. We have examined a detailed picture of how ancient engineering and social practices allowed people to survive in harsh conditions. Behind each of these solutions lies centuries of experience, a deep respect for nature, and care for their community. This level of adaptability shows that comfort and safety are achievable even without the use of modern industrial technologies. What other secrets of ancient civilizations' daily life do you think deserve our close attention? Suggest topics for future videos that you would like to see on our channel in the comments, and be sure to subscribe so you don't miss out on new research.